Let's consider the function f of x is equal to 3x exponent 5. What is its derivative? What is the derivative of this function? What is the differential coefficient, or what is its derived function? Now, the differential coefficient of a function or its derivative or its derived function mean the same thing. So if I'm to use these words interchangeably, do not be confused, they mean the same thing. Now, the derivative of a function is denoted by f prime or dy dx. For the purposes of this video, let's advert to the power rule method of differentiation. Now, if we are given a function which is of the form f of x, where a is a constant and n is the exponent, then the derivative of this function is given by, and here a and n are real numbers, but they should not be zero. So here it means that if we are to have a function of this form and we are asked to find the derivative of that function, the exponent, which is n, is brought down as a coefficient multiplying the original function, then we subtract 1 from the exponent. And here, this is the power rule method of differentiation. So if we are to consider the function f of x is equal to 3x exponent 5, then its derivative, f prime, is equal to, we bring the exponent 5 down to multiply the original function, then you subtract 1 from the exponent. So the derivative of this function is given by 15x exponent 4. Now we should take note that x is merely an independent variable. If the independent variable is called something other than x, then the variable changes accordingly. The independent variable can be p, it can be t, it can be anything. So when the variable changes, don't be confused about that. What of this function? What is the derivative of this function? And here, just going by the general rule method of differentiation, the differential coefficient j prime is given by, we bring the exponent down as a coefficient, then we subtract 1 from the exponent, and we are going to get the derivative of this function as negative 6x negative 4. And that here is the answer. What of this function? The differential coefficient of this function, the exponent is brought down and we subtract 1 from it. So the derivative of this function h prime is x exponent negative 7 over 4. Now, what if we have a polynomial? For example, y is equal to 3x power 4 to x cubed plus 5x squared minus 7x plus 1. Now, this is a polynomial having the sum and difference of more than 2 monomials. So the derivative of this expression is the sum or difference of the derivative of the separate terms. Now here, 1 is a constant and 1 can be expressed in terms of x as such. And here, x has the exponent 1. So the derivative of this polynomial, denoted by dy dx, is given by So this means the derivative is simplified further as and here the derivative of any constant is 0. So the derivative of this polynomial is given by 12s cubed minus 6x squared plus 10x minus 7. And that will be the answer for the derivative of this function. Y is equal to 3x exponent 4 minus 2 exponent 3 plus 5 exponent 2 minus 7 exponent 1 with a constant 1. So that is the answer. What about this exercise? Now, there are some of the expressions. To determine the derivative of those expressions, we would have to, first of all, rewrite the expression in its exponential notation. And here, specifically, the fractional exponent rule, which says that is given by... So here we would have to make use of this rule and rewrite this expression in the form and now in this expression, the independent variable is t. So the derivative of this expression is denoted by dy dt. And so the exponent is brought down and we subtract 1 from it. So dy dt is given by which can then be simplified as so the derivative dy dt is given by so that is the answer. Now, what if we have this? Put up this. So with this also, we're going to rewrite this expression in its exponential notation. And so we would also have to take into account another rule of exponents, which is known as the negative exponent rule, which says that if we have 1 over a, then this can be rewritten as, this is known as the negative exponent rule. So we're going to apply that over here. So first of all, we're going to apply the fractional exponent rule, and we are going to have this. Then we're going to apply the negative exponent rule, and we're going to have this. So in this fractional exponent notation, we can now go ahead and find the derivative of this expression as so we're going to simplify this. And go ahead with further simplification to get So the derivative of the function can now be given as cube root of x 7. So that is the derivative of this expression over here. What of y is equal to, what is the derivative of this expression over here? So here we would have to rewrite this expression into its fractional exponent notation. So we're going to have, so in this form, we can now differentiate. Take note of the independent variable, which is a q. So the derivative of this expression is dy dq is given by the exponent is brought down as 5/2. Then we subtract 1 from it, which can also be rewritten as, so simplifying further, we do have which means dy dq is given by dy dq is given by so this is the answer, and that is the derivative of this expression over here. So this is the end of my video. Thank you very much for watching, but keep watching.